Hello, everybody out there. This is Jason Quattlebaum. Welcome to another episode of DLT's ContinuousX podcast. I'm joined, as always, with Rick Stewart and Mike Fitzurka. And today we're going to talk about something that I've been hearing out in the public sector around customers. And wanted to get Mike and Rick's thoughts about that today, and see, what their opinions on, where, us as sales leaders and should be, instructing our customers to go, and what paths to look at. Rick and Mike, one of the things that I keep on hearing time and time, whether it's DoD, SLED, or civilian customers, is that they have these enormous systems, and they're just reluctant to modernize them due to fears, whether it's costs, time. Any suggestions you guys have out there for customers like this?
Yeah, well, I think it's important to solve the get to the root problem of the things that cause the drive to modernize. And there's a saying in the IT industry where applications do not age like fine wine, they age like milk. And the reason behind that is the longer you let your applications out there with, let's say, traditional workloads, maybe old versions of older languages, they tend to build up a series of vulnerabilities and exploitations that hackers, whether they be malevolent or benevolent, will expose and be able to access your systems, access your data, et cetera. So without modernizing, you really are exposing more every day as you don't modernize security holes that could be taken advantage of. The second one, or maybe second of many, we'll just discuss a few, is the availability of resources that can support these applications, these monolithic applications. Mike and I are old enough, and I know I am old enough. I've worked on COBOL systems. I worked on assembler systems, CICS. These are older technologies. And it's more mature veteran type people that can support those, because they're not, people coming out of college or being trained or not being trained in those languages and how they operate. So the pool from which you can gather resources to support your ongoing systems is dwindling as each year goes by. So the reason to modernize is to take advantage of the modern software capabilities that are built in, and take advantage of the resource pool that you have out there for your labor costs in order to build applications and use them properly, and to plug up any security holes you may have.
Now, I was going to comment on the aging like milk, because I enjoy cheese. But the 10-year-old sharp cheddar, that sounds great. Well, when you're talking about customers who might be reluctant to modernize, I tend, to think then that they're probably in a technical situation where it might be difficult to modernize. Maybe they have already an existing large monolith, or a large even a service-oriented architecture could be, a large scale that's difficult to modernize. And so it's not maybe a reluctance to, per se. Everyone wants something modern and new, but like, how do I get there from here? Like, I've got these large systems. What do I do? And one of the it's very much a technical solution to the question, but it's what came out of the time, and I've been around for a little bit of while. The enterprise servers bus, SOA era. One of the things that came out of that, or after that, was the advent of microservices, which kind of helps get people out of, when applied correctly, can help get people out of this monolithic architecture and help to modernize. Because the problem with the large systems is that, they can be difficult to change without having unforeseen consequences. There's scaling is a problem. If you want to increase your capabilities, you have to duplicate everything, not just everything's in one large architecture. All right, I'll make two of them, but now I've got more things that in some areas that I need, and maybe not enough in others. And even a small issue can take down the entire system when it's all one big application. So there's lots of problems with the larger architecture, and a smaller architecture that was kind of come out of that era was saying, hey, let's make a single application out of a collection of very small services, microservices. And the rule of thumb was, let's put one service to handle one function. I think that was a bit extreme. That's a bit of an exaggeration. It really, you should, anything that, if I change this, I've also got to change this, is a component. And if I want to scale this, I need these things to scale uniformly, then that's a component. That's something that's good as a minor microservice. And then you run that in its own container or its own process, individual, so that you can scale it separately. You can use containers in there. I mean, if you're going full out, I'd maybe suggest containers in there. But basically, it's not necessary. You just need it to be self-contained, and maybe use a lighter communication protocol like web traffic and APIs. That all came out of the same thing. And then you create these smaller services to take care of things, and slowly you can kind of drift your traffic from the larger systems to these smaller microservices, and then your larger system can size appropriately downward.
Now, Mike, microservices sounds interesting, but when you keep on adding, you're talking about adding more to the equation. And anytime you add more, I mean, doesn't that lead to more possibilities for, increased problems and, false positives or, operating costs going through the roof, more headcount?
Yes and no. I will clarify that. Certainly, none of the benefits of microservices come for free. Nothing comes for free. And where you might have one or a dozen large systems or monoliths, you could end up with hundreds, thousands of microservices. And the cost of that, as you pointed out, is operational complexity. It can really become problematic if not handled correctly. And also there's an increase in network traffic. So again, things that you need, as all these things are communicating with each other, the network traffic can go up. So, yes, there are. It's not for free. There are problems with that, but there are a lot of things that come out with cloud resources and containers, especially, that can add complexity to the mix. Especially because these things are more dynamic scaling. Now I've got things coming up and coming down. And now how do I track it all? Again, operational complexity. But there are a lot of external applications that you could use that help you track and manage these things more uniformly. Because, again, you have 1,000 different microservices, they all might report differently, or their statistics might be measured differently. They might even be in different languages and harder to support. But you let the smaller teams then handle that smaller change, and those smaller changes are easier to fix. So where there's operational complexity, you gain benefits in the fact that once you find a problem, you can fix it faster, because you're only taking down one very small application versus the entirety of the application that has to be planned months in advance. And there's a lot of applications out there, especially with the advent of the cloud and containers, that can help monitor these things uniformly and report on them, so that it doesn't necessarily require increased headcount to manage all of these additional operational the operational complexity. You can compensate that with automation and monitoring.
Coming from a management perspective viewpoint, tracking costs across programs and across projects, that becomes more and more difficult with microservices. And let me explain a little bit more. And I agree totally with Mike on all the different whys you want to do that. But then the challenges from a management perspective, from a financial perspective, become very, very obvious. From traditional monolithic systems where you could take a mainframe and you can take IPAC charges, you can split them off across cost centers, and you can divvy up the cost across many different projects and multi-tenant uses of your mainframe. People started going into the SOA environment and buying either their own servers or buying servers and then splitting them up into virtual machines. You could easily charge the project or the program for those services or their virtual machines. And then cloud comes along and you can still manage your on-demand charges, and you can scale up and scale down, as Mike mentioned, but your services were deployed in virtual machines, easily tracked. Now with the advent of containers, you now have processes that are distributed across many different hosts across the cluster. So you have thousands of processes or containers across hundreds potentially of hosts. How does one start to get an expense report of what you're actually costing the organization? So it's important to have technology, and I agree with Mike about automation, technology that understands that complexity and understands a Kubernetes environment that has the operational things that Mike talked about, making sure the container is up and running, it's available, it can scale up, it can scale down. But tracking the cost to the organization has to be a technology that understands the infrastructure and how it works. So it's monumentally important when you're undertaking microservices to keep a financial perspective in view, because you lose control of costs, you lose control of what's running, you've lost control of your system.
So should my customers start with microservices?
Well, I mean, the knee-jerk reaction is yes, it's the shiny new thing. Everybody go after it. The realistic viewpoint, especially in the public sector, is you're rarely starting out in an agency or department with no services, nothing to show. Microservices, if you're going to do Greenfield, yes, there's a way to do that, but it's usually probably for startups, for small teams, creating new projects, creating new innovative products that are literally out of brainstorming sessions. And that's great because you understand the problem more. The difference between starting out Greenfield in a public sector environment is you have existing services and capabilities already at your disposal. The last thing you want to do as a project team, and from a taxpayer perspective, is to build redundant services within that department. So if you go out and say, I'm going to create a microservices to do a login, et cetera, well, that's probably already built. So the key difference is to take a inventory of what's available in what are you trying to accomplish, and then start breaking down those monolithic systems and strangling them into smaller services to take advantage of everything that Mike said about testability, scalability, all those things. You want to get there, but you can't start sprinting out of the gate. You have to really understand your domain, your agency, and what you have.
And they've done a lot of testing, actually, for unicorn greenfield companies. It's even when you start with microservices, that can actually be problematic. That can lead to failure. So I think one of the leading thoughts, I guess, that works well with microservices, doing a domain-driven design. So you look at, what's my domain? Am I part of the billing world, or am I part of I'm going to present options to the user? What service are you providing? And keeping those domains as like I was mentioning, components, where you want things to scale appropriately. If I build an application that has certain help desk features to it, that might not need any more scaling. That might not need microservices, just because you mentioned, Rick, it's a shiny new hammer, everything's a nail. No, you can build a monolith to take care of the help desk functionality, because that's not going to scale. That's not going to have different things. Now, maybe you're creating a help desk application. That's the main thrust of what you're doing. Then you might want to focus on that as that's your primary domain. Then let me build this out in microservices because I know things are going to be heavily drawing on it. So it's sort of like anything. You want to attack what's the most important thing first with the best technology offering, and spending all your time building microservices and all the operational costs that come with microservices on things that are tangential or not as important as the main thrust of what you're doing, it isn't beneficial. And a lot of domain-driven design that's gets you thinking about what are my domains, what's most important to me, and that pairs well with microservices.
And one of the things, and I agree wholeheartedly, is when we're trying to solve for X in the ContinuousX equation for the software development life cycle, it's important to note that you should always be working towards value in your service. If you're building things for the sake of building microservices and it's redundant, it's already built, or maybe it's offered as a commercial off the shelf, then that might be the most beneficial thing to your organization. So there's no one size fits all. It has to be a unique strategy and both a strategy and a tactical approach, little by little, in order to create value for your organization to accomplish your mission.
Well, great. Thank you guys for bringing me up to date on these topics. This is definitely useful and something I'm going to take to my teams. And I hope for the listeners out there, you guys have gained something. So again, this is Jason Quattlebaum from DLT, and I'll let Rick and Mike say goodbye as well.
Well, thank you, listeners, for your time and your effort. This is Rick Stewart for DLT. Thank you.
Thank you.